Okay, so today I'm going to teach you how to come up with a list of K-mers that can be used to search DNA sequence. So we're working with DNA K-mers today. What a K-mer is a sequence of DNA of a particular length, the K, or the length is K. So in this case, we're working with a length of 2. And what we have here is we have the K-mer length of 2. We have nuke options 1, which is the 4 nucleotides, nuke options 2, which is also the 4 nucleotides, and we have the K-mers list. So the K-mers list is what we're wanting to get to. And we're ultimately going to output that as nuke options 2. It's because we update nuke options 2 every time we go through this loop. I've set this loop to only trigger if the K-mer length is less than 10. The reason for this is that you get such long, so many K-mers whenever you get lengths above 10 that it can crash your computer. So if you want it longer, you can set it longer. I just chose to set this at 10. So in order to create the K-mers, we basically use 3 nested for loops. So, and each time we go through this, so we're going to go through it the number of times that the K-mers, the length of the K-mers, essentially. So we start at 0 and we go to the length of the K-mers minus 1. So that means we go through it the same number of times as the length of the K-mers. In this case, we'll go through it twice. Nuke option 1 is the 4 bases, and those 4 bases will not change throughout this loop structure. But nuke option 2, which is also the 4 bases, you can think of this like the seed. We're going to update that each time we go through there as the K-mer grows to reaching its ultimate length. So, so each time we go through this loop, we're going to update the K-mers list. We're going to append Z, or the growing K-mer, with Y, which is the original set of bases, the nuke options 1. And then we're going to update nuke options 2 every time we go through these loops, these 2 loops here. And we're going to update it with the K-mers list. And then we're going to clear the K-mers list. So we're going to print nuke options 2 out, and that's what we're going to have as our list of K-mers. So I'll demonstrate for you real quick. A tumor, you get the list of 16 different K-mers. Let's go to 3. So we make our K-mer 3 long. Now we got a longer list of K-mers. We can go 4, 5, 6, or whatever. Now, this is a piece of code that is pretty widely used on the internet. So even though I did write this code, I can't really claim this logic as my own because it's very widely used. And another thing, it's going to be a series of videos. This first video is how to create the K-mers. The next video, I'll show you how to search a single sequence for each one of these K-mers and output that. And then ultimately, I'll show you how to search an entire file of DNA sequences, multiple DNA sequences for K-mers. So I hope this helps you out. I hope it gets you a little further down the line with your bioinformatics journey. If it does, please like the video and please subscribe to my page.